Welcome back to Mech Zone. In the previous lecture, we have finished with the entire theory on matrices and determinants, and from this lecture onwards, we shall be solving some important numericals and we will be applying that theory here in these important numericals. So before starting this lecture, I would simply like to request you that if you have not subscribed to our channel yet, kindly do it so by hitting the subscribe button and also press the bell icon for the important updates. I would also like to request you to kindly discuss about this channel with your friends and colleagues so that they are also benefited, because everything on this channel, be it the study material or the quality video lectures, they are available absolutely for free. You do not have to pay even a single amount of penny for anything which is available on this channel, and we have uploaded almost everything on this channel. The last topics remaining are mathematics and some portions of engineering mechanics. So we will be uploading that very soon. And let us start with the first problem of the day, where we have been given that we have matrix X of the order 4 cross 3 of Y 4 cross 3 and P 2 cross 3. Then we have to find out the order of P X transpose Y inverse P transpose whole transpose. So we have to find out the order of this matrix. Now we know that the two matrix will be multiplied only when the condition was satisfied, जो कि मैंने आपको अपने previous lecture में already बता चुका था. Now first we will try to find out the bracket one, X transpose into Y. So X transpose would be 3 cross 4 and Y is 4 cross 3. So column of this equals to row of this, hence the resultant, let us say Z, and Z will have the order of 3 cross 3. Okay, so Z का inverse हो गया यहाँ पे, because it has been raised to the power of -1. So the order of Z is same going to be 3 cross 3, because inverse does not change the order of the matrix. Now we will multiply, let us evaluate P transpose. P transpose would be P 3 cross 2. Okay, and now let us calculate P into Z into P transpose, and P is 2 cross 3, Z is 3 cross 3 and P transpose is 3 cross 2. Now since the column of this is equals to rows of this, hence let us say the resultant is R, such that R will have the dimension 3 cross 2 and P is having 2 cross 3. So column of this becomes row of this, and hence the order that would be obtained is 2 cross 2. Say we are having the resultant M. Okay, so the final answer that is coming out, that we have to find out, inside वाले का पूरा आ गया 2 cross 2. So M 2 cross 2, but we are having the transpose outside. So we see that even if we do a transpose, the order will still remain 2 cross 2. So the answer to this question simply becomes the 2 cross 2. Okay, and we must remember the property that A into A transpose is equals to the identity or the unit matrix. ठीक है, तो इस पे भी बेस कई सारे हमारे क्वेश्चंस पूछे गए थे. Now we will do a numerical which has been asked in the previous GATE exam, and it was given like this. Okay, we have been given a matrix of the order 4 cross 4, 1 1 1 1 1 1 minus 1 minus 1 1 minus 1 0 0 0 0 1 and minus 1. So this is the matrix of order 4 cross 4. We have to find out what is the value of A into A transpose inverse. Now some people, what they will do, they will calculate the A transpose and they will multiply it with A, and then they will take the inverse. But if you use the property of the matrices, this question can be solved in a single line. We know that for orthogonal matrix, A into A transpose is equals to I, or the identity matrix. So this would become identity matrix inverse, and inverse of the identity matrix is also equals to I. So the answer is going to be the identity matrix, but the order of this identity matrix will be same as 4 cross 4. So let us draw the identity matrix of 4 cross 4, 1 1 1 1, rest all the elements are going to be 0. So this will be the answer. So this is solved by using the direct property. Now let us solve a question on inverse, and we have to find out the inverse of the matrix A. It has been given as 1, 2, 5, 7. Okay, we have been given 1, 2, 5 and 7, and we have to find A inverse. So I will tell you the shortcut of solving this. If a matrix A has been given as A, B, C, D, then the inverse can be simply found out. We will interchange the position of these diagonal elements, that is D will come here, A will come here, okay, and we will change the signs of these two elements, that is here it is plus B, so we will make it as minus B, and here it is C, we will make it as minus C, okay, and we will simply divide by the determinant, that is AD minus BC. So this would be the A inverse. We will apply the same logic here. So what will be the determinant? First we will find out the determinant. 7 minus 10, that is minus 3, and now we will interchange the position of these two elements. 7 will be here, 1 will be here, and we will change the sign of these two, minus 2 minus 5, and we will divide it by minus 3. So अगर माइनस से पूरे में डिवाइड कर दें तो we will get minus 7, 2, 5 minus 1 into 1 by 3. So this finally becomes the answer. So this is how we are going to find out the inverse of 2 cross 2. However, for 3 cross 3, the procedure is a little bit tricky, and I will also be discussing about that procedure right now. Now I will discuss the shortcut for finding the adjoint. तो सबसे पहले हमारा तो मेन एडजॉइंट ही होता है, क्योंकि एडजॉइंट के बाद ही हम अपना इनवर्स कैलकुलेट करते हैं जस्ट बाय सिंपली डिवाइडिंग बाय द डिटर्मिनेंट. फॉर एग्जांपल वी हैव बीन गिवन अ डिटर्मिनेंट लाइक -1 -2 -2 2 1 -2 2 -2 1. Okay, and please note that this method is applicable only for 3 cross 3 मैट्रिक्स. ये सिर्फ 3 cross 3 मैट्रिक्स के लिए ही applicable है. So what we are doing is we are writing down these columns like this, such that what we are doing is we are going to repeat this first column at the last. -1 2 2. Okay, now what we will do is this multiplied by this minus this multiplied by this. So 1 into -1, sorry -1 into, just a second, okay, I am so sorry, this is not the procedure. We will not write like this. We will write it in the fashion that I am going to tell you. This is the first column, this is the middle column, and this is the last column. Okay, in the middle column we will move from the middle to the first term. लास्ट में भी यहां से लेके ऐसे लिखेंगे और फर्स्ट में भी ऐसे लिखेंगे, सच दैट मिडिल की अगर बात करें तो वी विल राइट 1 -2 -2 1 -2 और -2. देन वी विल राइट लास्ट -2 1 -2 -2 1 -2. देन वी विल राइट द फर्स्ट 2 2 -1 2 2 -1. Okay, and then again we will write the middle one, that is 1 -2 -2. ठीक है, अब हम क्या करेंगे, जो हमारा ये वाला कॉलम है, ये वाला जो हमारा है, इसी को हम लोग लास्ट में एक बार फिर से रिपीट कर देंगे. 1 -2 2 और 1. ठीक है, नाउ वी विल डू this multiplied by this minus this multiplied by this. This multiplied by this minus this multiplied by this. So 1 into 1 1 1 minus -4 would be -3. So here we will obtain -3. -2 into -2 is 4. 4 minus -2, that is 4 plus 2 is 6. Similarly we will obtain 6 here. Same with this. we will obtain -6. Here we will obtain 3. Here we will obtain -6. Here we will obtain -6. Here we will obtain -6. And for this we will obtain 3. So these elements that we have obtained, -3, 6, 6, -6, 3, -6, -6, -6, 3. This becomes the adjoint of A. So I am explaining it again. This is the middle column, this is the first column, this is the last column. We will write these terms in the clockwise manner such that starting from the middle element. So we will first write for the middle, that is 1, -2, -2. Then we have last one, -2, 1, -2. Then we have for the first one 2, 2, -1. So 2, 2, -1. And we will repeat the middle column once again, and we will repeat this column at the last. So this multiplied by this minus this multiplied by this, that is to solve the like determinant. So this minus this minus this minus this. This multiplied by this minus this minus this. So 1 1s are 1 minus -4. ठीक है, तो ये हो जाएगा 1 minus -2 into -2. So 1 minus 4, that is -3. So all these elements will be obtained, and hence the adjoint can be easily calculated. So this is the shortest method to find out the adjoint, and we will find out the determinant from this, and we will divide this by the determinant, so we can easily obtain the inverse of the matrix. Okay, so this was about the adjoint and the inverse. Now we have been given a question. A matrix R has been given as 1 0 -1, 2 1 -1, 2 3 2. देखिए, जब तक गेट में कैलकुलेटर अलाउड था तब तक तो मैट्रिक्स की प्रॉब्लम तुरंत हो जाया करती थी, क्योंकि ईएस वाले कैलकुलेटर में हमने मैट्रिक्स भी सॉल्व कर लेते थे आराम से और वहां डायरेक्ट आंसर मिल जाता था. लेकिन जब से कैलकुलेटर बंद हुआ है तो ये सारी चीजों में काफी हम मतलब इसमें दिक्कत आ रही है, तो इसीलिए हमें मैन्युअली करना पड़ेगा. तो यहां पर हमें फाइंड आउट करना है व्हाट विल बी द टॉप रो ऑफ आर इनवर्स. आर इनवर्स का टॉप रो हमें निकालना है. ठीक है, अब आर इनवर्स का टॉप रो निकालने के लिए सबसे पहले हमें क्या निकालना पड़ेगा, इसका एडजॉइंट निकालना पड़ेगा. ठीक है, तो एडजॉइंट जब हम निकालेंगे उसके बाद हम उसका ट्रांसपोज करेंगे. ट्रांसपोज करने के बाद हमें उसका इनवर्स निकलेगा. तो एडजॉइंट तो हम सिंपली इसी तरीके से निकाल लेंगे जैसे हमने निकाला, और एडजॉइंट करने के बाद फिर हम उसे ट्रांसपोज कर देंगे, और फाइनली जो हमारा आंसर आएगा वो आंसर आ जाएगा 5 -3 and 1. So 5 -3 1 is the answer corresponding to this question, such that the top row of R inverse would be 5 -3 1. Okay, now we will do some numericals related to the rank of a matrix. Now there are certain rules or certain shortcuts that I'm going to tell you that you have to remember to calculate the rank. The first shortcut is that we have to convert the given matrix in either the upper triangular matrix or the lower triangular matrix. Generally हम लोग अपने मैट्रिक्स को अपर ट्रायंगुलर मैट्रिक्स में ब्रेक कर लेते हैं. ब्रेक कैसे करेंगे? सिंपली बाय अप्लाइंग एलिमेंट्री ट्रांसफॉर्मेशंस. एलिमेंट्री ट्रांसफॉर्मेशंस लगाकर हम अपने मैट्रिक्स को अपर ट्रायंगुलर मैट्रिक्स में कन्वर्ट कर लेंगे. अपर ट्रायंगुलर मैट्रिक्स इज वन इन विच द एलिमेंट्स लाइंग बिलो द लीडिंग डायगोनल आर ऑल 0. फॉर एग्जाम्पल वी हैव 1 2 3 2 4 6 7 9 1. So what we will try to achieve is we will try to break down all the elements which are below the leading diagonal as 0. तो इस वाले एलिमेंट को 0, इस वाले एलिमेंट को 0 और इस वाले एलिमेंट को हमें मेनली 0 बना लेंगे, तो हमारा ये अपर ट्रायंगुलर मैट्रिक्स में टूट जाएगा. अब अपर ट्रायंगुलर मैट्रिक्स में ब्रेक करने के लिए वी विल फर्स्ट स्टार्ट विद दिस एलिमेंट. मतलब सबसे पहले हम इसको 0 बनाएंगे, देन फॉर दिस, एंड देन वी विल मूव फॉर दिस. तो एक शॉर्टकट लैडर है जो हमें फॉलो करना है. यहां से यहां, मतलब सबसे पहले यहां वाला एलिमेंट, फिर यहां वाला एलिमेंट, फिर यहां वाला एलिमेंट, फिर हम गए ऐसे, फिर ये वाला एलिमेंट, फिर ये वाला एलिमेंट, फिर यहां से गए ऐसे, ये वाला एलिमेंट, ये वाला एलिमेंट, फिर यहां से आ गए यहां ये वाला एलिमेंट, फिर आ गए हम यहां पर, फिर यहां वाला, मतलब सबसे लास्ट में मिडिल एलिमेंट को 0 करेंगे और सबसे पहले फर्स्ट वाले को। तो इस तरीके से हमें ऑर्डर में चलना है, एंड बाय फॉलोइंग दिस ऑर्डर द evaluation of rank will be very very simpler. So let us solve one question which was asked. We have been given a matrix and this is 4 2 1 3 6 3 4 7 2 1 0 1. Now this is a 3 rows and 4 columns. This is a 3 cross 4 matrix. Okay, now since it is a 3 cross 4 matrix, the first property, that is rank of A, is less than or equals to minimum of 3,4. मतलब तो मैक्सिमम पॉसिबल रैंक क्या हो सकती है? 3 हो सकती है, 4 हो ही नहीं सकती, रैंक कैन नेवर बी 4. तो हम लोग क्या करेंगे, क्योंकि रैंक 3 हो सकती है, तो वी विल ट्राई टू फॉर्म ऑल द 3 क्रॉस 3 माइनर्स. हमने अब इसमें सबसे पहले 3 क्रॉस 3 माइनर्स यूज करेंगे. पहला माइनर हम ये ले सकते हैं, दूसरा माइनर हम ये ले लेंगे. ठीक है, तो एक बार करके देखिए, 4 2 1 6 3 4 2 1 0. तो अगर इस माइनर को अगर आप सॉल्व करें और इसका आप डिटर्मिनेंट निकालें, सो डिटर्मिनेंट इज कमिंग आउट टू बी 0. ठीक है, नेक्स्ट जो हमने लिया माइनर 2 1 3 3 4 7 1 0 1, 2 1 3 3 4 7 1 0 1, इसका भी अगर आप डिटर्मिनेंट निकालें, इट इज कमिंग आउट टू बी 0. नेक्स्ट जो हो सकता है वो हो सकता है 4 6 2, मतलब ये वाला कॉलम, ये वाला कॉलम और ये वाला कॉलम, 1 4 0 3 7 1. तो अगर इसका हम लोग निकालें, ये भी आ रहा है हमारा 0. ठीक है, और एक और केस बन सकता है हमारा, जो कि है 4 2 3 6 3 7, मतलब ये वाला कॉलम, ये वाला कॉलम और लास्ट वाला कॉलम अगर हम लें, 4 2 3 6 3 7 2 1 1. So this is also coming out to be 0. So almost all the possible cases of 3 cross 3 are coming out to be 0. Hence the rank is not equals to 3. Rank मतलब 3 नहीं हो सकती, क्योंकि हमारे सारे 3 cross 3 के minors are coming out to be 0. Now we will go for the 2 cross 2 minors. So 2 cross 2 minors के तो बहुत सारे cases हैं. एक माइनर ये है, तो 4 3 12 माइनस 6 2 12, तो 12 माइनस 12 0 आ गया. ठीक है, अब ये चेक करेंगे, 4 2 8 माइनस 3, तो 8 माइनस 3 क्या आ गया 5, विच इज नॉट इक्वल टू 0. तो एक भी ऑर्डर का माइनर अगर 0 नहीं आ रहा है, देन दिस सिंपली बिकम्स द रैंक. तो कौन से ऑर्डर का माइनर 0 नहीं है? 2 क्रॉस 2 ऑर्डर का माइनर इज नॉट इक्वल टू 0 एंड हेंस द रैंक इज इक्वल टू 2. Okay, so the rank is simply coming out to be 2. Okay, now I will solve one more question based upon this rank. So here we have been given a matrix 1 1 1 1 minus 1 0 1 1 1. So we have to find out the rank of the matrix. Now I have already told you that we will first try to break this matrix into the upper triangular matrix, and in order to do it, we have this as the leading diagonal, so we will try to make this and this term as 0. So this term can be simply made 0. R2 is equals to R2 minus R1, and R3 is also replaced by R3 minus R1. So 1 1 1, first row to remains unaltered, then this minus this 0, this minus this minus 2, this minus this minus 1, this minus this 0, this minus this 0, this minus this 0. ओके, तो हमारा ये तो पूरा 0 आ गया. ठीक है, अब हम फिर से और ट्राई करते हैं कि काश कहीं हमारा एक और कोई 0 बन जाए, मैक्स और 0 बनाने की कोशिश करें. अगर आप देखें यहां पे R1 is replaced by R1 plus R2, अगर यहां करने की कोशिश करें तो 1 plus 0 1 हो गया, 1 minus 2 minus 1 हो गया, 1 minus 1 0 हो गया, ये भी 0, minus 2 minus 1 0 0 0. ठीक है, तो एक तो ये कंप्लीटली 0 आ गई आपकी रो. तो एक 0 आ गया, मतलब रैंक आपकी 3 नहीं हो सकती. So rank cannot be equal to 3 because this is a matrix of the order 3 cross 3 and the rank of A is less than or equals to the minimum of 3, 3. So the maximum rank can be 3 only. But here we see that there is one complete 0 row and hence the rank is not equals to 3. Now after this we cannot make any more zeros. So number of non-zero rows that we are obtaining is 2. Non-zero rows simply means that each and every element is not 0. However, there is one 0, it is immaterial. So इस वाली रो में अगर आप देखें तो यहाँ सारे के सारे elements 0 नहीं हैं. Hence the number of non-zero rows that are obtained is 2. Hence the rank of the given matrix becomes 2. So this was the method that I was talking about. We are going to make the upper triangular matrix and then we are going to solve further. Okay. Next we have the topic of orthogonal vectors. Two vectors are said to be orthogonal. Say a vector A and a vector B are said to be orthogonal if, that is, if and only if A transpose into B is equals to 0. So this is the condition for the orthogonality of two vectors. If the product of the transpose of the first and second it is equals to 0, then we have the two vectors as orthogonal vectors. For example, 1, 2 and -2, 1. So 1, this is A, this is B. They are orthogonal if 1, 2 transpose multiplied by -2, 1 is coming out to be 0. So 1, 2 transpose simply 1, 2 multiplied by -2, 1. So how we are going to multiply it? This is of the order 2 rows and 1 column. So 2 cross 1. This is of the order 1 cross 2. So number of columns of first are equal to the number of rows of the second. Hence the resulting matrix would have the order of 2 cross 2. Okay. Or we are going to very simple multiplication would be 1 into -2 plus 2 into 1. So 1 into -2 plus 2 into 1, and this is coming out to be 0. Hence these two vectors, that is A and B, are orthogonal vectors. So this was the condition for the orthogonality of vectors. And how we are going to find out the magnitude of a vector? Say we have been given a vector like 1, 2, 1. This has been given as A. So what would be the magnitude of this vector? The magnitude of this vector would be 1 square plus 2 square plus 1 square. This is 1 plus 4 plus 1 under root. This is under root 6. So this is how we are going to find out the magnitude of this vector. That is simply under root of A square plus B square plus C square. So this was about the magnitude and this was about the orthogonality of two vectors. Okay, we have one more type of vectors that is called as orthonormal vectors. And what are these orthonormal vectors? A vector is said to be an orthonormal vector if it is orthogonal. It should be an orthogonal vector, and secondly it should have a unit length. That means the magnitude should be equals to unity. So if a vector is satisfying these two conditions, then it would be called as the orthonormal vector. Okay, so this was all about the rank and the vectors in matrices. Now we will start with the portion of system of equations. Okay, and in the system of equation, the first question that we will solve is, we have been given for what value of alpha and beta the equation will have infinite number of solutions. Now since it is having infinite number of solutions, it means it is consistent first of all, and for infinite number of solutions we know rank of A is equals to the rank of the augmented matrix. It is less than n, where n is actually the number of unknowns. Okay, m is actually the number of unknowns. So the equations that have been given to us are x plus y plus z equals to 5, x plus 3y plus 3z is equals to 9, x plus 2y plus alpha z is equals to beta. So from these equations we will find out the matrix, that is 1. 1 simply refers to the coefficient of this term. Then 1, 1, 1, 3, 3, 1, 2, alpha, x, y, z, and this is 5, 9 and beta. So this is the matrix representation of this given problem. Now we know that the number of unknowns here are x, y and z, hence n is equals to 3. The number of equations that have been used, m is equals to 3. Okay, now we will find out the augmented matrix, and augmented matrix would be simply 1, 1, 1, 1, 3, 3, 1, 2 alpha, 5, 9 beta. Okay, this is the augmented matrix. Now we will find out the rank of the augmented matrix, and since it is given infinite number of solutions, that means the condition should be satisfied that rank of the augmented matrix should be less than 3. Okay, जो हमारी augmented matrix की rank होनी चाहिए, it should be less than 3. Now we will convert it into upper triangular matrix. Okay, upper triangular matrix. Now what we will do is we will simply have R2 minus R1 and R3 minus R1. So when we will subtract it, we will get 1, 1, 1, 5, 0, 2, 2, 4, 0, 1, alpha minus 1, beta minus 5. Okay, so यहाँ पर हमारे 2 zeros already obtain हो गए और हमें इस diagonal के नीचे इस element को भी finally 0 करना है. So what we will do is we will simply go for R3 is replaced by R3 minus 1 by 2 times of R2. So we will divide this entire row by 2 and we will subtract it from 3. So what we will obtain 1, 1, 1, 5, 0, 2, 2, 4 and we will obtain 0, 0, alpha minus 2, beta minus 7. So now this matrix has been converted into the upper triangular matrix such that all the elements lying below this diagonal are 0. So now since we have infinite solutions, since solutions है वो कमलेश वाला solution नहीं है, वो जो आप लोग ने सुना होगा वो बिल्कुल नहीं है, देखिए that is very dangerous for health. You should not get addicted to any of the drugs. It has been seen that during the BTech time many of the students are addicted to some or the other thing. So try to keep yourself as far as away from all these things. So below this diagonal we have 0, 0 and 0. So in order to have infinite number of solutions, the rank should not be equals to 3. That means the rank should be less than 3. So rank less than 3 simply means the rank has to be 2. And in order to make the rank equals to 2, we should get this entire row as 0. For getting this entire row as 0, alpha minus 2 should also be 0 and beta minus 7 should also be 0. So what would be the value of alpha? It would be 2 and beta it would be 7. So for alpha and beta both equal to 2 and 7 respectively, this entire row will be 0 and hence we will obtain the rank of A would be equals to 2 and rank of the augmented matrix also becomes 2 and rank of A becomes the rank of the augmented matrix which is less than 3. 3 was the number of unknowns and this is the condition of infinite number of solutions. So condition is also satisfied and the values have also been evaluated. So value of alpha is 2, beta is 7. Now we will do one more important question. We have been given a matrix A 2, 1, minus 4, 4, 3, minus 12, 1, 2, minus 8, x, y, z, it is equals to alpha 5, 7. Okay, and we have been asked for what value of alpha will the system of equations have infinite number of solutions. For what value of alpha will the system have infinite number of solutions? For infinite solutions, we have rank of A is equals to the rank of the augmented matrix should be less than n, where n is the number of unknowns here, which is equals to 3, that is x, y and z. So we will now form the augmented matrix 4, 3, minus 12, 1, 2, minus 8, alpha, 5 and 7. Okay, now what is it? We will apply the elementary transformation processes and we will try to form the upper triangular matrix, that is the elements which are lying below these should be 0. So the first operation that we will apply is R2 is replaced by R2 minus 2 times R1, क्योंकि यहाँ पे 4 है तो यहाँ पूरा 2 से मल्टीप्लाई कर देंगे फिर सब्सट्रैक्ट करेंगे, ठीक है. And R3 is replaced by R3 minus R1 upon 2. R3 minus R1 upon 2, क्योंकि यहाँ पर -4 है, यहाँ -8 है, तो इसको हमने क्या कर दिया 2 से डिवाइड करके फिर हमने उसे R3 में से सब्सट्रैक्ट कर लिया. तो we will obtain 2, 1, -4 alpha. First row will remain unaltered. Then we have 0, we have 1, -4, 5 minus 2 alpha, क्योंकि 2 times R1 कर दिया है. And here we will obtain 0, 3 by 2, minus 6, and this would be 7 minus alpha by 2. Okay. So now what we will do, another elementary transformation, R3 minus 3 by 2 times of R2. ठीक है, इसको पूरे को 3 by 2 से मल्टीप्लाई कर दिया और R3 को अब हम उसमें से सब्सट्रैक्ट कर लेंगे. तो ये 2, 1, -4, this was alpha, 0, 1, -4, this is 5 minus 2 alpha, this is 0, 0, 0, 5 alpha minus 1 upon 2. Okay, now we see that this row will be entirely 0 for this value also equals to 0. So 5 alpha minus 1 upon 2 अगर 0 हो जाता है तो यहाँ से हमारा alpha is equals to 1 upon 5 आ जाएगा. Okay, so for alpha is equals to 1 upon 5, we will have this entire row equals to 0, and if this entire row equals to 0, then rank of A becomes the rank of the augmented matrix becomes 2, which is less than the number of unknowns, and hence this is a case of infinite solutions. Okay, this is the case of infinite solutions, and hence the value of alpha 1 by 5 satisfies the given solution. So this was all about the rank of the matrix, and now we shall be discussing about or solving the problems related to the eigen values and the eigen vectors. Say for example, we have been given a matrix A 9, 5, 5, 8. Okay, and we have to find out the eigen values. So we will first form the characteristic equation, that is A minus lambda I is equals to 0. So A is 9, 5, 5, 8 minus lambda times I means 1, 1, 0, 0. This is equals to 0. Now we have already learned that in case of the matrix, if any number is multiplied, then it gets multiplied to the entire matrix. So 9, 5, 5, 8 minus lambda 0, 0 lambda. So if we will subtract it, we will get 9 minus lambda 5, 5, 8 minus lambda, and this is nothing but equals to 0. So we will take the determinant, that is 9 minus lambda 8 minus lambda minus 25, this is equals to 0, and the equation will be forming lambda square minus 17 lambda plus 47, this is equals to 0. So lambda values will come out to be, I'm directly writing the answer, 3.48 and 13.53. So these become the eigenvalues of the matrix. Now another question which was asked, a matrix A has been given as 4, 1, 1, 4, and we have to find out the eigenvalues, and the options were given as 3 and minus 3, minus 3 and minus 5, 3 and 5, 5 and 0. Now you can also find out the eigenvalues simply by calculating the characteristic equation values, that is A minus lambda I, this is equals to 0. Now this is a long procedure. Now for the short procedure we will apply the property, that is two properties we have to keep in mind. The trace, that is the sum of the diagonal elements, is equals to the sum of the eigenvalues, and secondly the determinant is equals to the product of the eigenvalues. So trace of the matrix is coming out to be 8. So trace is coming out to be 8, that means lambda 1 plus lambda 2 should be equals to 8. Now in this case 3 plus minus 3, it is 0. So this option is ruled out. Minus 3 and minus 5 are minus 8. So this is also ruled out. 5 plus 3, 8. Yes, we are getting 8. So this is the correct answer. So without even writing a single equation, you can directly get the answer. And this was also asked in Mechanical Gate 2003, and it was for just 1 mark. Now we will discuss a question on the Eigen Vectors. Okay, so the question that was asked is, we were given a matrix 1, 2, 0, 2, and the Eigen Vectors were written in the form 1a and 1b. Okay, then we have to find out what is the value of a plus b. The value of a plus b has to be evaluated. So first of all we will find out a minus lambda I equals to 0, and from here we will find out the lambda 1 is equals to 1 and lambda 2 is equals to 2. These are the eigen values. So 1 minus lambda 2, 0, 2 minus lambda. Okay, this was the characteristic matrix, and this will be multiplied by x such that this is equals to 0, where x is called as the eigen vector. Okay, this will be called as the eigen vector. Now what we will do is, we will first keep the value of alpha equals to 1 here, and we will solve the matrix. So when we will keep the value of alpha is equals to 1, we get 1 minus 1, 2, 0, 2 minus 1 x bar. This would be equals to 0, 2, 0, 1 x bar. Okay, and this is nothing but the value has been given as 1a. Okay, we can clearly see that here the determinant would be equals to 0. Okay, that means if we will multiply 0, 2, 0, 1 with 1a, we will obtain a as 0. Okay, so the value of a is coming out to be 0. Now in this particular equation we will keep the value of alpha equals to 2. So we will obtain 1 minus 2, 2, 0, 2 minus 2. This is equals to 1b. Okay, so this would be minus 1, 2, 0 and 0. Into x bar is equals to 1b. So we will multiply this by this matrix and we will find out the value of b, and we will find that b is coming out to be 1 by 2. So a was 0, b is 1 by 2. So a plus b would simply come out to be 0 plus 1 by 2, and that is 1 by 2. So the answer for this question becomes 1 by 2. Okay. Okay, we will solve one more question related to the eigenvector, and a matrix has been given as 2, 2, 1, 3, and we have to find only one of the eigenvectors. So a minus lambda I would be equals to 0. This would be the characteristic equation. 2 minus lambda 2, 1, 3 minus lambda is equals to 0. So we will find out the value of lambda, and they are coming out to be 1 and 4. Now a minus lambda I x bar is equals to 0. This is the eigenvector. Okay, this is the eigenvector, and first in this equation we will keep lambda is equals to 1. So for lambda is equals to 1, we have 2 minus 1 is 1, 2, 1, 2. This x can be written as x1, x2. This is equals to 0. Now since the first row and the second row are same, the value of the determinant would be equals to 0. So if we multiply x1 plus 2x2 is equals to 0, x1 plus 2x2 is equals to 0. Okay, so in such case we will assume either x1 is equals to k or x2 is equals to k. Let x2 is equals to k. So x1 is equals to minus 2k. So we have minus 2k and k, such that the vector, अगर k यहाँ से common ले लें तो हमें जाएगा minus 2, 1. Okay, so minus 2 and 1, this can be the eigenvector for the given matrix. Okay, so now we will discuss the last portion of this chapter, and that is Cayley-Hamilton theorem. Okay, now according to the Cayley-Hamilton theorem, every square matrix satisfies its own characteristic इक्वेशन, मतलब हर स्क्वायर मैट्रिक्स अपनी कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. फॉर एग्जांपल वी हैव बीन गिवन a 1 3 4 2, देन द कैरेक्टरिस्टिक इक्वेशन विल बी 1 minus lambda 3 4 2 minus lambda equals to 0. So this would be lambda square minus 3 lambda minus 10 is equals to 0. Now since A is a square matrix, that means the rows and the columns are same, therefore it will satisfy its characteristic equation. A square minus 3a minus 10 is equals to 0. So this is actually according to the Cayley-Hamilton theorem. Now by using this Cayley-Hamilton theorem, certain questions were asked and I will be discussing those questions. Now for example, we have been given a matrix A 1 3 4 2, and we have to find out a to the power 5 as a linear polynomial in A. So what we will do is we will first try to form the characteristic equation which we have already formed, that is a square minus 3a minus 10 is equals to 0. Okay, so a square minus 3a minus 10 is equals to 0 is actually the characteristic equation of this matrix, which is being satisfied by the square matrix, that is A. So from here we know that a square is equals to 3a plus 10. Okay, and we will not write 10, we will write 10i because it is I is the identity matrix. So simply 1, so it was multiplied by I. So now we will find out the value of a cube. A cube is simply a square into a. Okay, so we will multiply a square with a, so we will get 3a square plus 10a. Okay, now if again we have a square, so we will substitute, instead of a square we will write 3a plus 10i. So 3 into 3a plus 10i plus 10a, we will get 9a plus 30i plus 10a, we will get 19a plus 30i. This is the value of a cube. Now we will find out the value of a to the power 4, which is a cube into a. So we will multiply this by a and we will obtain 19a square plus 30a. Now instead of a square, we will keep the value of a square here and we will solve 19 3a plus 10i plus 30a. So after solving, we will obtain a to the power 4 as 87a plus 190i, because we have to keep it in the linear powers, because question में हमें linear power में पूछा गया है, so we cannot have the square or the cube. Now a to the power 5 is simply a to the power 4 into a. We will multiply, so a to the power 5 comes out to be 87 into 3a plus 10i plus 190a, and it is 451a plus 870i. So we have expressed a5 in the linear polynomial as a linear polynomial in the terms of a. So with this we come to the end of this lecture, and we have covered almost all the problems which have been asked in GATE from this chapter of matrices and determinants. And in the next lecture we shall be starting with the numerical methods.